All right, this is the notes for segment addition postulate. So first we got to fill in what the segment addition postulate is. So the segment addition postulate says if 3 points are collinear, so we'll say we're going to just use A, B, and C, but it could apply to any letter you choose. So if A, B, and C are collinear, right, meaning on the same line, and B is between A and C, then we conclude that AB plus BC is going to equal AC, right? The distance from A to B plus the distance from B to C is going to equal the distance from A to C. So what that looks like, if we draw it out, we have 3 points. We have A. Okay, that's a little chintzy. Let's do, we have A. That's a little thick. Let's do 3. Okay, we got A here. We got B over here, and we got C over here. So B is between A and C. So that's just saying if, let's say AB was 4 and BC was 5, the distance from A to B is 4, the distance from B to C is 5. That means the distance from A to C would be 4 plus 5 added together, which is going to be 9. Okay, so that's really all it's telling us. The first segment, the length of the first segment plus the length of the second segment is going to equal the length of the whole thing. Okay, as long as the middle letter is between the other two. All right, let's look at our examples down here. So A, we can also delete this. Okay, so the first one, let's zoom in a little more. Okay, so the first one here, the first segment, we're going to write it out. So we're going to say LM, that's the first piece, plus MN equals the whole thing, which is L to N. So there's our segment addition postulate. So we want to justify our equation. So I'm going to justify that by over here, I'm going to write segment addition postulate. That's what I use to get this equation right here. I use the segment addition postulate. All right, now I'm going to go ahead, once I have my equation, okay, the distance from L to M, we're just going to call it X. Okay, plus the distance from M to N is 3. And then the distance from L to N, the whole thing is going to be 10. So I'm substituting in their substitution. Okay, and then I'm simply going to solve. I'm going to subtract 3 on both sides. So minus 3 from this side, minus 3 from this side, and I end up with X equals 7. So my missing length here, LM, is my missing length. It's going to be equal to 7 units long. Okay, they don't tell if it's inches or centimeters or whatever, so just 7 units. We can just put 7. Okay, so we have our justification for our equation, which is LM plus MN equals LN. We substituted in the values. We don't know LM, so we put X. MN is 3. LN is 10. And then we just simply solved. Okay, and then the one you guys would have done together in class, so we would have KL as the first piece, plus the second piece, which is LM, equals the whole thing, which is KM. That's our segment addition postulate, right? If L is between K and M, then KL plus LM equals KM. So again, I'm going to type in over here, segment addition postulate. That's what I'm using. I'm using the segment addition postulate. Okay, this piece is, we're going to call it X. We don't know it. So KL is 8 plus LM is X, and that's going to equal KM, the whole thing, which is 13. I subtract 8 on both sides, and I end up with X equals 5. Minus 8, that gave me X equals 5. Okay, so that means my solution then is going to be LM. The missing piece is LM. And LM is going to equal 5 units long. Okay, 5 plus 8 gives us 13. All right, second type of problem gets a little trickier. Not in, in the algebra. The algebra gets trickier. The geometry aspect of it does not get any trickier, but the geometry might. So let's also clear objects. Yep. Okay, so the second one, we're going to do the same thing. We're going to use the segment addition postulate. So the first segment or the first piece is DC plus the second piece, which is CB, equals the whole thing, which is DB. Okay, the distance from D to C plus the distance from C to B is going to equal the distance from D to B. And that is the segment addition postulate. So again, we're always going to explain where our equation is coming from. It's coming from the segment addition postulate. That's where it's coming from, and we need to include that. Okay, so we know the distance from D to C is 2. Plus, we know the distance from C to B is x minus 4. We don't know the value, but we know it's an expression, x minus 4. And then the distance from D to B is 2x minus 10. All right, we need, in order to find BC, we need to solve for x first and then substitute it back into this expression right here. So to solve it, I'm going to first combine like terms. So I'm going to do 2 minus 4. That's going to become x minus 2. Okay, I can't combine anything anymore on each side of the equal sign, so I'm going to try to get all my x's on one side. I'm going to subtract x on both sides. That's going to leave me with minus 2 equals 1x minus 10. And then when I add 10 on both sides, I get x equals 8. Whoops. I get x on this side, and x equals 8. So we're not done yet. We want to know what BC is. So BC, we know, is equal to x minus 4. We now know that x is 8. So 8 minus 4 is going to give us 4. So the length of BC, or the distance from B to C, is 4. If we want to check our answer, we can also substitute 8 in here. 2 times 8 is 16. 16 minus 10 is 6. So we know 2 plus 4 is going to give us a total of 6. Looks like we did it right. Okay, and then yours that you were going to do here is the same. Okay, numbers might be a little different though. D's in the middle, so the length or the distance from C to D plus D to E should equal the whole thing, which is CE. So again, we're going to do 8 plus x minus 3 equals the whole thing, which is 2x. Okay, we need to justify our equation. We always need to justify our equation with a geometry reason. So a theorem, definition, or postulate, or property. So again, this is the segment addition. We're adding segments together. Segment addition postulates. Okay. All right, combine like terms on each side of the equal sign first. So I'm going to have x plus 5, right? 8 minus 3 is 5. Now I have x's on both sides. I'm going to subtract x from both sides to get all the x's on one side. 2x minus 1x is 1x. So I get x equals 5. I'm looking for CE. That's the whole thing. So CE equals 2x. So that means CE is going to equal 2 times 5, which means CE is equal to 10. If I want to check my answer, I can plug it in here too, substitute as well in here. 5 minus 3 is 2. 8 plus 2 gives me 10. Okay, perfect. Clear objects, clear annotations. Okay, next one is the same thing. We can go through them real quick, but it's the same process. You have GH plus HI equals the whole thing, which is GI. So we get 11 plus 2x plus x plus 11 equals 10, right? When we substitute it in, combine like terms, we get 3x plus 22 equals 10. Ooh, we're going to end up with a negative here. This is not going to be good. Okay, subtract 22 on both sides. Okay, we're going to end up with 3x equals negative 12. When you divide 3 on both sides, you're going to end up with x equals negative 4. Oh, no, we're good. Okay, so when we substitute this back in for GH, right, we're going to get 11 plus 2 times negative 4, which is going to be 11 minus 8, which is going to be 3. Right, so x can be negative. The value of x can be negative as long as your distance is positive. The distance from g to h is positive 3. Okay, and then same thing here. Negative 4 plus 11 is going to be 7. 3 plus 7 gives us 10. So it looks like our answer is pretty good. Okay, and then this one, same thing. We have DE plus EF equals DF. And again, we would have to justify. We'd have to say this is segment addition postulate. This is segment addition postulate. Okay, you get 2x plus 12 plus x plus 11 equals 8. You'd combine like terms. 3x plus, that's 23. Subtract 23 on both sides, and you end up with x equals negative 15. Divide by 3 on both sides, we end up with x equals negative 5. We're looking for EF. So that's going to be negative 5 plus 11, which gives me positive 6. If I want to check my answer, I should plug here as well. 2 times negative 5 is negative 10. Negative 10 plus 12 is 2. 2 plus 6 gives me 8. Okay, and we do, again, want to remind you how you need to justify your equation. So segment addition postulate. This needs to be on your assessments, right? You need to justify where your equation is coming from. Segment addition postulate. And again, same thing over here. We should have written them in. Segment addition postulate. Okay. Wonderful. All right, that's the first side. Now we can go over to the back. Okay, a bisector cuts things in half. So a segment bisector is going to split a segment in half. So the first one here, okay, JK is getting bisected by line L. So that means that this piece and this piece are congruent. They're the same length. So we can say JT is equal to TK. The reason we can say that, the mathematical reason we can say that, is because that's what a bisector is. We have a segment bisector. So I'm going to say definition of a segment bisector. That's what a segment bisector does. It splits evenly in half. Okay, so then I can say 3x plus 6 equals 15. In order to solve for x, we need to subtract 6 on both sides. So I get 3x equals 9. I divide by 3 on both sides. I get x equals 3. If I want to check my answer, I can substitute it back in. 3 times 3 is 9. 9 plus 6 gives me 15. So we got 15 and 15. Okay, over here it says line L bisects segment PQ. So again, that means we're splitting segment PQ in half into 2 congruent pieces, 2 equal pieces. Okay. So we can set up the equation. PM equals MQ. Okay, and the reason we have that equation, right, is the definition of a segment bisector. So definition of segment bisector. Right? Line L is splitting PQ into 2 even pieces. All right, now we can set up our substitute in. So PM is 5x minus 7. MQ is 11 minus 2x. Okay, I can't combine anything on each side, so I'm going to start by adding 2x to both sides. That's going to give me 7x minus 7 equals 11. I'm going to add 7 to both sides. That's going to give me 7x equals 18. Divide 7 on both sides. I'm going to get x equals a fraction, 18 over 7. Okay, it wants us to find PQ. That's the whole thing. Okay, so when I substitute that in for PM, I have 5 times 18 over 7 minus 7. Okay, and I'm going to put that all in my calculator. I'm just going to use my calculator. So 5 times 18 divided by 7 minus 7. That's going to give me 41 over 7. So this piece is 41 over 7. Okay, and then MQ. So this was PM. MQ is going to be the same thing. It should also be 41 over 7, but let's put it in. 11 minus 2 times 18 over 7. So let me just put that in my calculator just to double check and make sure I didn't make any mistakes. That's also going to give me 41 over 7. Okay, so then if I do PM plus MQ, that's what's going to give me the whole thing. Right? So 41 over 7 plus 41 over 7 gives me 82 over 7. And that's going to be my final answer. PQ is going to be 87 over 2. Okay, and what are we doing down here? If we wanted to add that in, we're doing segment addition. Segment addition. Right? MPM plus MQ should add up to PQ. Okay. Equals PQ. This is 41 over 7. So when you add them together to get the whole thing, we got 82 over 7. All right. That's good. Let's do the fifth one. Clear annotations as well. All right. So these ones, they don't give you a diagram. You just have to use the information that they're giving you. So it says B is between points A and C. So I can draw my diagram. Here's A, and here's C, and it says B is between. So we're going to put B here. Okay. AB. Find AB if AC is 10. So we know the whole distance across here is 10 from A to C. We know the expression for AB is x minus 2, and the expression for BC is x plus 2. Okay, so this was modeling, right? We've drawn our diagram. Okay, we did some modeling. All right. From there, we're going to set up our equation. So we know that AB plus BC should equal AC, right? B is in the middle, so we just use the segment. Oops. Nope. Segment addition postulate. AB plus BC equals AC. Okay, now we can substitute those values in. So we have x minus 2 plus x plus 2 equals 10. All right, so combine like terms on this side of the equal sign. That's going to give me 2x. And then negative 2 plus 2 is 0. So it just ends up being 2x equals 10. Divide by 2 on both sides. I get x equals 5. Okay, we're looking for AB. So AB here. Oops, AB is equal to x minus 2. That means AB is equal to 5 minus 2, which is 3. Okay, if we want to check our answer, we can do the other one as well. 5 plus 2 is 7. 3 plus 7 gives us a grand total of 10. So if AB has a length of 3, BC has a length of 7. Okay, AC is going to be 10. So that makes sense. All right, same thing for this next one here. A, B, and C are collinear with B between A and C. So again, we're going to draw our diagram. Here's A. B is in the middle between A and C. Okay, this time they're telling us BC is 5, AB is 2x, and then AC, the whole thing, is -3 plus 4x. Okay. All right, and again, we can use our segment addition postulate. B is between A and C, so AB, AB plus BC is going to equal AC. And again, the reason for that, the reason that's true, is the segment addition postulate. Okay. Once we have our equation, we can substitute in the pieces. AB is 2x, BC is 5, and then AC, the whole thing, is -3 plus 4x. Okay, I can't combine anything on each side of the equal sign, so I'm going to start by getting all my x's on one side. I'm going to subtract 2x on both sides. That gives me 5 equals -3 plus 2x. I'm going to add 3 to both sides, which gives me 8, 2x. Okay, divide by 2 on both sides. I end up with 4 equals x. Okay, that's not my final answer because I'm looking for AC, right? So we don't want to circle it just yet. We're looking for AC. So then AC is -3 plus 4 times 4, which is going to be 16 minus 3, which should be 13. If we want to check our answer, 2 times 4 is 8. 5 plus 8 gives us a total of 13. All right. So the difference here on these is you just had to draw your own diagram. All right, and then the last two, a little bit challenging here, but it's going to be the same idea. I'm not going to go ahead and solve all of them for you or all the way for you, but I'm going to give you a little bit of help to start. Okay, we know the distance from F to H here is 13. Right? So if the distance from F to H is 13, these two pieces should add up to 13. So this one's going to have to be 7. 13 minus 6 is 7. So if I wanted to come up with an equation, right, I could do EG, because we have EG, plus GH, and that's going to equal the whole thing, which is EH. Okay, and then when you substitute in, you'd have 3 plus 3x, right? That's EG, plus GH, which is 7, equals the whole thing, which would be 6x plus 1. So that would be one way to go about solving it. Okay, this one over here. Again, you should know this piece, right? If this distance is 6, this distance here from D to E has to be 3. 3 plus 3 is 6. Okay, so then to come up with an equation, I could just use this piece right here. I could say DE plus EF equals DF. And then I would have 3 plus 2x plus 17 equals x plus 14. Okay, so you don't need to use all the pieces all the time. You just got to use whatever you can to get those solutions. Okay, so that's it for the notes. Let's see. I think I have to go back here to end the meeting.